Question 12 says a piece of land is being fenced by a housing co-op to provide ground for some residents so that they may have vegetable gardens. The land is divided into 5 sections with fencing as shown in the diagram. If 96 meters of fence are used to enclose a maximum area, what are the overall dimensions of the piece of land? So looking at this diagram we've been given, I'm just going to label some of these sides with variables. I'm going to call this shorter piece here L, and we can see that we have 1, 2, 3, 4, 5, 6 pieces of length L, and I'm going to call this whole section here W, and that's going to be the same as on this side. And so we know that the overall area of these 5 sections can be given by the equation A equals L times W. And the other piece of information we've been given in our question is how much fence has been used. So that's the perimeter, sorry, not the perimeter, but exactly how much fence has been used to divide up all these sections. So that is equal to 6 times L for all these pieces in the middle, plus 2 times W for these pieces on the sides, and that added together is going to come to 96 meters of fence. So looking at this equation here, what we want to do is rearrange this to get one variable in terms of the other, and W looks a little bit easier to solve for. So what I'm going to do is subtract 6L on both sides, and that's going to give me 2W is equal to 96 minus 6L. And dividing by 2 on both sides of the equation gives me W is equal to 96 divided by 2, which is 48, negative 6 divided by 2, which is negative 3L. So the next thing I want to do is go back to this equation here for the area, because the area is what we've been told is reaching a maximum. So we want to rewrite this equation so that the area is all in terms of one variable. So I'm going to plug in this expression for W in here, and this gives me area is equal to L times 48 minus 3L. And I'm going to multiply that L into the brackets, and that gives me 48L minus 3L squared. And I'm just going to rearrange this a little bit to put my L squared term at the front. And this is just to make it a little bit more obvious that what we have here is a function that's in the form y equals ax squared plus bx plus c. And what we want to do is change this function to the form y equals a times x minus p squared plus q, because this form makes it a little bit easier to see where the vertex is, and the vertex is going to be our maximum area, which is the situation that we're interested in. So what I want to do here is figure out how to change each of these variables so we can change the form of the function, and that information has just been given in your notes, the equations that relate these variables. A is the same in both cases, so A in this situation is just equal to negative 3. It's the coefficient on the squared term. And for our variable P, in your notes it's been given that P is equal to negative B over 2A, and B in this case is 48, so we have a negative 48 on the top and 2 times negative 3 on the bottom. So this gives us negative 48 over -6, and that evaluates out to +8. And for Q, the equation is Q equals 4AC minus B squared over 4A. So we have 4 times -3, which is our value for A. And C in this case is 0, because we don't have a term here that doesn't have an L in it. So C is 0. And we're subtracting B squared. B again is 48. So that's a 48 squared. And that is over 4 times -3. So this term here evaluates out to 0. 48 squared is 2,304. That's going to be negative. And that is over 4 times -3, which is -12. So 2,304 divided by 12 is 192. And so now we have our values for A, P, and Q, and we can rewrite this function in this form. And so doing that here gives us big A area is equal to -3 times L minus 8 squared plus 192. And so looking at this equation here, this tells us that the vertex of our function is at 8, x equals 8, y equals 192. And since our a is negative, we know that this quadratic function is opening downwards, and so this vertex is a maximum. And since y in this case corresponds to a, our area, 192 is our maximum area that we have. So we know from this vertex, moving up here, that our max area equals 192 meters squared. But this question is asking us for the overall dimensions of the piece of land. So what they want to know is the values for L and W here, as we've assigned it. So our vertex also tells us what our value for L is at this maximum area. So just looking at our vertex, we can say that L at our max area of 192 is 8 meters. And then to figure out W, it's just a matter of plugging in this value for L in either this term here. So we can do that by saying W is equal to 48 minus 3L, and plug in 8 for L. That gives us 48 minus 24, which is equal to 24. So value for W is 24 meters. Another way to do that is to realize that our max area is 192 meters squared, divide by our length, 8 meters, that gives us 24 meters. It's a good way to check that all our work makes sense. And so the answers to this question are the dimensions of this piece of land are 8 meters by 24 meters.